Aquaculture is the fastest growing food production sector globally, and it actually exceeded wild capture fisheries in terms of seafood produced for human consumption in around 2014. More importantly, it's been proposed as one of the most sustainable sources of animal protein production, and it's one of the only ways we can sustainably increase seafood production to meet human demand. But it faces a number of significant challenges that might mean its capacity to meet demand is uncertain, and these include things like climate change, disease. And overcoming these challenges are vitally important to ensure aquaculture can maximise and meet its potential, and we can produce enough seafood for human consumption. Through our research at Exeter, we're undertaking experiments that use animal physiology to optimise aquaculture ecosystems. How can we optimise the environment using the function of the animal, and how can we target environmental conditions that really maximise productivity and reduce adverse health? One of the main solutions proposed within global aquaculture to enable us to optimise productivity and overcome challenges like disease is to move production from where it's currently happening, largely in earthen ponds in Southeast Asia, indoors. By doing so, you move animals from ponds into tanks, but that gives you much greater control of the environmental conditions you're growing them in. These systems are typically called recirculating aquaculture systems, or RAS. And RAS are much more technologically advanced and therefore enable us to undertake animal production in a controlled, benign environment. So what is an RAS? Well, an RAS is a system that you grow animals in indoors, much like a small home aquaria. So the system comprises of, firstly, of a tank which you would hold your animals in, usually quite high density. Obviously, this system is kind of moving and aerated to keep conditions as close to optimal as possible. And what happens is then the water flows out of that tank and it carries all of the wastes with it, all those solid wastes and all of the wastes that are dissolved in the water, and they are then taken through a different treatment system. Firstly, the solid wastes are removed mechanically and they can be used and recycled. Then the water is treated further biologically through a biological filter, and then using things like UV and ozonation to remove the microbial biomass to really keep those conditions optimal. The critical thing about recirculating aquaculture systems is then they loop back, and it's a completely closed system with only very little water replacement each day. And this means they're super sustainable, there's very low water use, but also there's very little input, so you can keep control and they're very biosecure. Another benefit of such a system is it means you can grow pretty much any species anywhere in the world. And a really good example of that is a research project we're just starting at the University of Exeter, looking at king prawns, Penaeus vannamei. So Penaeus vannamei are one of the kind of most highly consumed species of seafood in the UK. They're in the top 5 retail species. We really like to eat them. Now, we import 28,000 tonnes of warm water prawn every year to eat in the UK. And typically these are coming from Southeast Asian ponds where they're grown in these outside earthen ponds. However, the research that we're undertaking is looking at, can we move production to the UK to make it much more sustainable? And by doing so in an RAS, it allows us to manipulate the temperature in that system to grow a species, the tropical king prawn, in a UK context where otherwise it would not be possible. So this technology and this research is allowing us to create new sectors in different regions and really improve the sustainability of that sector. However, there remain a number of challenges that we need to overcome as part of the project to make sure that this is viable. And one of the main things is that sustainability and the fact that it's a tropical species. So how can we create a sector where it would need so much heating to keep this production viable?
So the UK Sustainable King Prawn project, which we're undertaking here at Exeter University with partners at Reading University and Rothamsted Research, is doing this in a really innovative way. So essentially we are pairing social scientists with natural scientists to see if we can create a brand new sector for growing king prawns indoors using recirculation systems in the UK based on farm sites. And doing this by co-locating with anaerobic digesters on these farms to provide the most renewable sources of energy to heat these tropical species to their optimum temperature. So anaerobic digesters are a fantastic way of using farm wastes such as pig slurry, cow manure and things like that, and making the most out of them before you then dispense with them. They do this by placing the wastes inside the anaerobic digester building, which uses microbes to convert all of that waste, or most of it, into biogas, which is methane. you can then either sell that to the mains or burn it on site to produce renewable electricity. But one of the wastes coming out of anaerobic digesters is heat. And heat is much more difficult to utilise because you can't transport it over long distances. However, if you can find something that can utilise that heat and you put it next door, it's an excellent way of maximising the outputs from the anaerobic digester. And that's exactly what we plan to do using our king prawn farms co-located next to anaerobic digesters, using the heat to warm this tropical species to their optimum temperature. That actually makes it possible to grow a tropical species like king prawn here in the UK with minimal additional cost associated with heating the water.
Another sustainability gain by using king prawns and growing them in the UK is we remove that production from Southeast Asian ponds, where typically a number of different sustainability issues exist. For example, mangroves, one of the world's best sinks of carbon and best defences against climate change, are being destroyed and removed to produce new prawn ponds. In these regions, often antibiotics are often used to overcome disease. And then obviously there's the issue of transportation. So by moving production closer to home, we can overcome many of these sustainability challenges and create a brand new sector in the UK.
The first part of this project involves social sciences modelling to understand both the economic viability but also the potential environmental benefits of switching from an outdoor type system overseas to an indoor system using renewable sources of energy here in the UK. The modelling should reveal which parts of the UK lend themselves most to taking advantage of incentives from the government as part of the new Agricultural Act to incentivise and facilitate public goods for public money. The benefits that could arise from this include things like the reduction of greenhouse gases and water pollution, and the enhancements of biodiversity, circularity of wastes, and the public use of recreational land, as well as boosting the renewable energy sector based on farms. The second part of this research is involved in the lab, where we're looking at optimising the conditions we grow the prawns in, specifically improving the water chemistry and the food we give them to maximise the health of the animals, the production, as well as the nutritional value to us humans. Vital to this goal is innovation of the technology currently used to monitor the water chemistry that the prawns live in. Specifically and importantly, calcium is critical because the prawns need lots of calcium to harden their exoskeleton or their shells, which they molt in order to grow. So, finding calcium sensors that allow us to do this in real time would be a really critical improvement within the industry.
So by the whole assessment of this process, we can look at the sustainability gains and the economic viability of actually being able to create a king prawn project in the UK and all of the associated sustainability benefits, both within our shores and also more wider afield. Really importantly, a lot of the learning that we're going to be doing and a lot of the research is going to then be directly applicable to other systems and other new species that might be needing a warm water production setting in the UK. We're also partnering with Exora Energy. This is an anaerobic digester operation just outside of Exeter. And as part of this project, what we're going to do is actually create a commercially viable demonstration model outside to produce king prawns in the model that we're developing co-located with anaerobic digesters. So through this project, working with a whole range of project partners and co-investigators, is going to allow us to address this problem from all different angles and really produce an amazing wealth of information to really make sure that if we're going to be able to create a king prawn project in the UK, we're going to be able to do it in the most sustainable and economically viable way.